Okay, remember that we can have something called composition of functions. Something f is a function of g is a function of x, right? You have a composition of functions. So what we want to find out now is how to find the derivative of that function. As an example, let's say hx is sine of x cubed. See, there are two functions involved here. Sine of fx, where fx is x cubed. So, or let's call it gx. So this is kind of like f of g of x, where f function, f of x is the sine function and g of x is the x cubed function. So when you do a composition of that, f of g of x, it is sine of g of x, x cubed. That's this function. So if you have that, the question is, what is the derivative of this with respect to x? Okay. So what we will find is that the result is, in fact, it looks straightforward. So df or g of x with respect to x, so this will be d of f over d of g and d of g over d of x. It sort of looks like that, oh, this is sort of like some cancellation. I mean, that's not what is going on here, but this is an easy way to remember it, and it's called the chain rule. df, so the question is, what does it mean for this case here? Sine of x cubed. So it will be, take the derivative of f with respect to g. So treat x cubed as some y. So sine of y, if you have sine of y and you take derivative with respect to that y, right? What do we get? We get cos of y. So cos of g. But our g is, so cos of g times derivative of x cubed, which is 3x squared. But what is g in our case? So remember, our f function was sine x, but our g function is x cubed. And f of g of x is sine of x cubed. See, it's f of g of x. So when we do df over dx, it becomes df over dg times dg over dx. But remember here it's x cubed, so this is sine of g. So what is sine g? D of sine g over dg, that is cos of g, times derivative of x cubed. Now what is g? G, as we just said, is x cubed. So it becomes cos of x cubed times 3x squared. Okay, so the chain rule basically says that if you have sine of x cubed, so sine of g of x, where g of x is x cubed. So what you do is df over dx is df over dg times dg over dx. df over dg means, because it's sine of g, so derivative of sine of g with respect to g is cos of g. So df over dg becomes cos of g times dg over dx. That's just simple because that's g of x is x cubed. So derivative of x cubed with respect to x, 3x squared. So that's the chain rule. And the way to motivate here, we are saying that derivative of a function, hx, right? Which is this, so derivative of any function, f of f prime of x at a is given by limit h goes to 0, or let's say at x, it's f of x plus h minus f of x over h, right? Now, so this is can be shown as if this is x and this is x plus h. So we take f of x plus h minus f of x over this distance, and which is h in this case. However, if let's say we call this a and if we call this x, this point A, this point x, and we rewrite this derivative at A, not at x now, at A. So this becomes that f prime A is limit, this distance goes to 0, right? H goes to 0 was, this is x and this is x plus h. This distance goes to 0 can be shown as x goes to A. See, x goes to A, which means the distance goes to 0. And fx plus h has become f of x. Minus f of x has become f of A. Over, now instead of h, because this distance was h, we have x and A. So we write the distance as x minus A. So we can also write our definition of a derivative at a point A as limit x goes to A, fx minus fa over x minus A, as compared to f prime at x is f of x plus h minus f of x, right, over h, limit h goes to 0. These two are equivalent. You can choose either one. So here in the book, they're saying, okay, let's try to find the derivative of h of x, where h of x is sine x cubed, where x at A, at x equals A. Okay, so I just showed you the definition can be equivalently. The derivative is x goes to A, f of x minus f of A over x minus A. So this function sine of x cubed minus sine of A cubed over x minus A. Because these two statements are exactly the same. Okay, but now what we can do is we can multiply and divide by this and take the limit x to A, this limit here as well as here. Remember, if you have a limit of product of two functions, f times g, it becomes limit of f times limit of g. Okay, and this is just the derivative. If you look at this part, it'll be limit x goes to A, x cubed minus A cubed over x minus A. This is just the derivative of x cubed, okay, which is 3x squared, and evaluated at A becomes 3a squared. So second part is straightforward. Now this part, we can write it as, treat x cubed as u, sine of u, and this is A cubed, u minus A cubed, and as x goes to A, then u goes to A cubed, right? And this becomes derivative of sine u evaluated at A cubed cos A cubed. So we can prove this general theorem of chain rule, and the result is as follows. If you have a composite function hx, okay, which is hx is f of g of x, the derivative is f prime at g, or with respect to g, times g prime of x. Or in the Leibniz notation, if you have y, oops, let's use this. If y is a function of u is a function of x, and you want to do dy over dx, it is dy over du times du over dx. Okay, now let's just apply to many examples, and the more you apply, the easier it becomes. Okay. So let's see, for example, we have function gx to the power n. Okay, so it's a power function. See, if you have function, so the f function is, so this is f of g of x, where f takes gx and puts a power n to it. So if you want to do d of h of dx, right, it will be derivative of this function. So d of dx of this will be derivative of this f with respect to g times dg over dx. Now, for example, if you had d of x to the n with respect to x, we know it would be nxn minus 1. But you can replace x by g. So d of g to the n over dg is ng n minus 1. Now g is just g of x everywhere. So that's the result we get for this part. So this is n of gx to the n minus 1 times the derivative of g with respect to x. So this seems a little tricky in the beginning, but when you apply it a few times, it becomes easier. Okay, instead of doing this one, let's start with something maybe simpler. So let's say we have sine x to the power 3. Okay, this is our function, and I want to find the derivative of this. So this again, it's f of g of x. What is our f function? F is the cube function, because we're taking a cube of sine x. So that means if we take a derivative of this with respect to x, this is df over dg, dg over dx. Okay, what is g here? Sine x. F is the cube of that. So df over dg will be 3 times sine x to the power 2, right? Just like here, our gx is sine x, and n is 3 in this case, times derivative of g, which is sine x with respect to x, which is cos x. So this is the answer. 3 of sine x squared, or 3 sine squared x, times cos x. Okay? Similarly, if you had square root of sine x, this is our function. It's a square root. F is the square root of gx. G is sine x once again. So the derivative of this function, so this is hx, derivative of this would be, so remember this means sine x to the power half. So once again, our gx is sine x, n is half, so the result is half, sine x to the power half minus 1, so negative half, times the derivative of g, which is sine x, cosine x. That's the derivative. So the function is square root of sine x. The derivative of that becomes half cos x over square root of sine x. Okay, so here we write our hx as 3x squared plus 1 to the negative 2. So our gx is 3x squared plus 1. So our result is negative 2 times gx to the power negative 2 minus 1, which is negative 3, times the derivative of the inside part, which is 6x. Okay, so this gives us the result. What about this one? Okay, this will be, the derivative will be, this is gx here, 4 times gx to the power 4 minus 1, 3, times the derivative of this gx, which is 6x squared plus 2. Okay, so please do some practice so you get comfortable with applying chain rule. So here is sine x cubed. I already did this, right? So h prime x is 3 times sine square x times the derivative of our g here is sine x, so times cosine x. Okay, 3 sine square x cosine x. Okay, find the equation of a tangent line at x equals 2 So finding tangent lines, once you know the derivative, the formula of the derivative, you apply that at that point, x equals 2, you get the derivative, then you have, again, you have some function and you have the slope, so we need h prime at 2. So take the derivative, apply x equals 2, find h prime 2, and then we know the point is 2, and then evaluate h at 2. Once you know that, then y minus h of 2 over x minus 2 equals h prime of 2. Take this on that side and you get the equation of the tangent. Just go through the details here. I won't keep doing this tangent line examples. Now we can also combine chain rule with other rules, right? So cos of gx, find the derivative of that. So this is cos of gx. Cos is f, and then we have gx. Okay, so this will be derivative of cos with respect to g. Okay, so which is negative sine of g times derivative of this. Okay, so negative sine of gx times g prime of x. That's the chain rule. For example, here, cos of fx squared. So the derivative will be cos of g. If you have to take a derivative of cos of g with respect to g, it's negative sine of g, but our g is 5x squared, times derivative of 5x squared, which is 10x. So we get negative 10x sine 5x squared. Okay, please practice enough with chain rule problems. Secant. Okay, remember, derivative of secant x is secant x tan x. So if you say derivative of secant of gx or g with respect to g, it will be secant of g times tan of g. And then if you have to do dh, which is secant of g of x, this is secant of g of x. So derivative of secant of g of x with respect to x is derivative of secant of g over dg, this one, times dg over dx. So it will be secant of g, so our h prime will be secant of g times tan of g times g prime x. But our g is this, so, and g prime is easy, 20x4 plus 2. So plug these two things here and get the result. Okay, find the derivative of this is sine of gx. So derivative of sine of g with respect to g is cos of g. So cos of 7x plus 2 times the derivative of this with respect to x, which is just 7. So 7 cosine 7x plus 2. Okay, so this is just, written for convenience, but you should be able to do any of this. That derivative of sine of g with respect to g, like if you say d of sine of g with respect to g, of course is cos of g. But if it is derivative of sine of g of x with respect to x, it'll be derivative of sine of g with respect to g times dg over dx. Remember, if y is a function of u is a function of x, then dy with respect to dx is dy with respect to u times du with respect to dx. So please check these out, each one carefully. Okay, now let's see the chain rule with the product rule. So again, once you know all the rules and derivatives of some basic functions, then you can find derivatives for more complex functions. So this is u and this is v, u, v. So derivative of, remember, d of uv is u dv plus v du. So this will be 3x minus 2, this is v, times derivative of u, which is this. Then u, this, times derivative of this. Now to find derivative of this, you independently apply the chain rule, and to find this, you apply the chain rule. Okay, and then multiply by this power. So chain rule means 5 times 2x plus 1 to the power 4 times derivative of 2x plus 1 with respect to x, which is 2. Similarly here, 7 times gx to the power 6 times derivative of 3x minus 2 with respect to x, which is 3. Simplify, you get the result. Now this one, very similar, is just u over v. So derivative of u over v, as you remember, is v du minus u dv over v squared. So our v squared becomes 2x plus 3, 6. And then v, which is 2x plus 3 cubed, times derivative of x, which is just 1, minus x times derivative of this, which is, what is the derivative of 2x plus 3 cubed with respect to x? It's a composite function, right? So g cubed, so it becomes 3 times g n minus 1, so 2 times derivative of 2x plus 3 with respect to x, which is 2. So it becomes 6 2x plus 3 squared. So you put this here. So it becomes 6x 2x plus 3 squared. Okay, so I keep saying it, practice a lot of chain rule problems. What if you have 3 functions? Okay, so very similar. It becomes dk of dx is dh over df, df over dg, dg over dx. What you can see is it seems like, look, this is this and this and this and this. They cancel, it becomes dh over d. I'm sorry, this is dk here. Oh, which is shown to be h here. Okay, k of x as a function of x is, so dh of df, df over dg, dg over dx. So just h to f, and then f to g, and then g to x. So 3 derivatives. Okay, and so here to do this one is cosine to the power 4, so g to the power 4. So we will do with respect to, so here, so it becomes, so k prime becomes, bring 4 down here, keep the whole thing as is, to the power n minus 1, 3, times the derivative of cos of 7x squared plus 1. So this part is done, only this part is left. Now this is cos of this function, and you know how to do this one. So do another chain rule on this one. So the first step, we got 4 out to the power 3, and then the derivative of the inside. So f of g of h of x. This is the power to the 4. G is the cos function. So this is 4th power. G is the cos function, and hx is this inside part. So first we did df over dg. df over dg gave us 4 g to the power 4 minus 1, 3 times the derivative of the inside part. And now here you will break it down again. This is the derivative of cosine, which is negative sine of the inside part, times the derivative of the inside part, which is of course 14x. And simplify. Okay, I'll leave the velocity problem for you to go through. And same by applying, and we talked about Leibniz notation already. So yeah, rest of these you can go through yourself.